Hello everyone, welcome to the fifth video of this series on Simulink model for electrical circuits. In this video, we will implement a single phase half wave controlled rectifier on Simulink. So rectifier circuits basically they are used to convert the analog signal into digital. Okay. So since this is a controlled rectifier, so we will be using a thyristor circuit. Now this thyristor circuit, it can be triggered by applying a gate signal at this port. So basically by applying a clock pulse at different angle, or we say it as firing angles, we can trigger the rectification process, or rectifier can be triggered at different angle. So for this half wave single phase controlled rectifier thyristor circuit, uh, which is connected to a 10 ohm resistor load, uh, and we have to trigger it at uh, 10 degree, 45 degree, 60 degree and 90 degree firing angle, and we have to measure the output voltage, and we have to also observe the waveform, right? What effect this firing angle has on the waveform. Okay, so let us now go on to Simulink and try to implement this circuit. Okay, so to implement this circuit on half wave controlled rectifier, the first thing we will need is an AC voltage source. Okay, so let's search for it. We are going to use this one, and the the RMS voltage is given as 220 uh, volts. So since we have to enter the peak voltage here, so we have to multiply it with square root of 2. Okay, so 220 multiplied by square root of 2. The supply frequency is 50 hertz. Okay, the next thing we will need is your thyristor. Okay, so let's search for it, and the one we are going to use is at the bottom, this one. Okay, so we can connect it here. So let's turn on the block name. Now another thing we'll need is the load resistor. Okay, so we are going to search for this series RLC branch, and I'm going to rotate it. Now I don't need the RLC branch. Instead, I only need the resistor of 10 ohms. Okay, so I've changed it to resistor of 10 ohms. Okay, so almost all the components that I need in the circuit, they are there. So I can just connect them something like this. Okay, now for the measurements, so I will need to measure the current, the voltage, or the supply voltage, as well as the voltage across the load resistor. So again I will need the current measurements and the voltage measurement. Okay, so I'll have to connect it here. apply current, you can say, and I need the voltage measurement. Okay, so one voltage measurement, I'll be using it here, and I can call it as supply voltage, and the other one I'll be using it here. So that will be my load voltage. Okay, so I can connect it something like that. Okay, now to trigger this thyristor, I will need a pulse generator. Okay, so a pulse generator. So we are going to use the second one here. Okay, now uh, let's turn the name of the block on. So now if you double click on this pulse generator, we are going to make some changes in the parameter. Okay, so the amplitude, it should be 10. Okay, and the period, so again the frequency is 50 hertz, so accordingly I'll set the time period for the square pulses. That will be 20 e to the power minus 3, that is 20 millisecond. Pulse width is okay, 5, and the phase delay, so I'm going to use a variable angle. Okay, so that will allow me to change the firing angles. Okay, so I will tell you how to set the value of this angle of this variable, okay, later on, but let's now, for the time being, let's use this variable. Okay, divided by 360 multiplied by 20 e to the power minus 3. Okay, uh, so time should be use simulated time. Okay, so I've set the pulse generator and everything, and I can connect the load voltage across the load like that. Now I will need to display the values, so I'm going to use a scope to display the waveforms. So I want to display the voltage, the current, and the pulse generator output. Okay, so I will need 3 inputs. So let's change the number of input port to 3. Okay, so the bottom input, I'm going to connect it to the pulse generator, and the second one I'm going to connect it to the current. The first input, I'm going to connect it to the supply voltage. Okay, so that's my scope. I then have to measure the load voltage. Okay, so this time let's use a block called mean. So that will give me the mean or the average voltage. So if you search for mean uh, and scroll down, you will get this block here. Okay, so we can connect that, and obviously we will need a display, a number display. Okay, so we can go down and select this one. Okay, now this is the main block, so let's turn on the name, and this is displaying my mean or average voltage. Okay, now the stop time, you can change it to 0.06. Okay, so we will display 3 complete cycles. Okay, now the last thing is uh, the last thing is obviously don't forget to add the power GUI block. Okay, so let's add it here. Okay, anywhere in the circuit, and now if we run the circuit, hopefully it should run. Okay, so we have run the circuit for 10-degree firing angle. Okay, let's first check the output. So let us display it on 3 different graphs. Okay, now you can change the color by going into view and style. Okay, so for the active display, let's leave it as yellow. For the active display 2, let's change it to red, and for active display 3, let's change it to blue. Okay, something like that. And if we run it again, let's turn on the legend as well. Okay, so this is the 10-degree firing angle. So at that angle, as you can see, the controlled rectifier starts producing your uh, DC voltage after 10 degree. Okay, now if we change, now let's change the firing angle to 45 degree, and then let's run the circuit again. Right, so as you can see, this has moved to 45, and again the rectifier circuit is generating the waveform after 45 degree or phase, after 45-degree phase. Okay, now one thing I think I've forgotten is to change the fundamental frequency. Okay, so don't forget to do that, and let's run the circuit again. So it's coming out to be 83.98. Okay, now if we check the value for 10 degree as well, value of mean average voltage, it is 97.39 for 10 degree. Okay, so we have already verified it for 45-degree angle, and let's again change the angle to 60. Okay, so again let's run the circuit. So the mean voltage or the average voltage is 73.82, and you can see the again it further move or shifts towards the right. Okay, and finally if we check the value and the waveform for 90 degree. Okay, run the circuit again one last time. So there you go, at 90 degree firing angle, almost it's kind of clipping almost half of the rectified output, and the average voltage is coming out to be 49.25. Okay, now coming back to the slides to verify the calculations or verify the observed value or measured value in Simulink model using calculations. So basically these are the values which we have observed in Simulink for different firing angles. Okay, so we can use the formula here to calculate the average voltage for a half wave rectifier, and you can see there is nearly uh, some difference of around 1 volt between the calculated and the um, measured value. Now this usually happens because of the thyristor. So this thyristor, it has a forward voltage of zero point 0.8. Okay, so that's why that's causing a difference in the calculated and the measured value. Okay, and in the waveforms, as we have observed that for 10 degree firing angle, um, the the output of the rectifier, it started after the corresponding time, right? There was a phase difference or there was a time delay after the rectification process starts, and as we change this firing angle or as we increase the firing angle, this further this delay in the rectifier's output is also increases. Okay, so this is all that I wanted to discuss with you in this video. Uh, in the next video, we will discuss or we'll try to implement the full wave rectifier, full wave controlled rectifier circuit. Okay, so thank you very much for watching this video and hope to see you in the next video.